Hello everyone, welcome to EduCell. Today's session is all about to find time complexity. So here we will get to know how to find the time complexity in iteration method only. Like the number of times the function is the number of times the statement is getting called. We will get to know is all about the iteration, okay, or iteration you can say. The example that I have given is the first example is like the for loop is there, then how to find the time complexity, that could be a vital role. That we should know each statement will run for one time. You simply write times here, okay, or time you can write. So how many times we are running? Always the statement will run for one time if condition is running for one time. Now for loop, though there is a problem how to how much time it will run, it based on the condition. Everything is based on the condition that we know. So here you check for zeroth time, it will start running. First it will check zero. Suppose let us think n is suppose 2. In that case it will be checking like I value is 0, whether 0 is less than 2 or not. If this, then get into the statement. Once this is over, then it will reach to the increment or decrement operator. Once it is done, then it will fetch to the condition. Once the condition will be success, then get into this uh, part of the code which is written within the for loop. Okay, this is how it will run. Now as per this condition, what we are actually finding, it is running for n times. That we are trying to find it, we simply write this for loop. We are running for n times because 0 to n, but it will have to check the false condition. The false condition will be, why we have to check, because we need to go for the total correctness. For getting the total correctness, you have to go for the stopping property. You have to check the stopping property. It has to stop if this value will occur, means either I is greater than n or I is equal to n. This is how it will stop. If this happened, for stopping it, we have to run for one more time, okay, to check the stop condition. Then within that, it is written within any for loop what exactly the conditions based on the statement it is there as for the for loop. So the first, how many times it is running, that will be written only, okay. Like this will run for n times, not for n plus 1, because plus 1 is for to check where to stop. A stopping property, a stopping criteria, we are using this one. So the number of times we found will be the time complexity. Then so then how to find the time complexity? Just add it, okay. Complexity will be by adding this 1 plus n plus 1. I'm just putting a bracket to make you more clear about it. Next you write 2n plus 2. So here we will get to know like there are 2n plus 2. So you can say if n equal to 1, both the side 2 equal to 2. Okay, if n equal to 2, so one side is 4, another side is 2, which is 2n is greater as compared to the constant. So that is why we are writing big of n. It is a correct answer. Sometimes you can say big of c into n, where c is the constant. This is also correct because constant is getting multiplied. As practically, that should be correct, c into n, or theoretically big of n, if you are saying, it's also correct. It's linear time complexity it is taking. Now the next example is run, so it's running for a one time. Clear? Next, for this, whenever you are actually focusing how many times it is running, always remember the I is getting incremented with plus 2. Clear? When it is running like this, so you can say suppose n value is 8. Okay, suppose n value is 8. For this, what to be printed? Check here, like 0. 0 will have to check with whether it is less than 8 or not. Yes, it is less than 8, then it will be printed. Next, 0 plus 2, which is 2. 2 is less than 8 or not. Yes, 8, then print 2. Next value will be 2 plus 2, which is 4. whether 4 is less than 8 or not. Yes, 8. Then write 4. Then 4 plus 2 is 6, whether 6 is less than 8 or not. Yes, so print 6. Then it will check whether 6 plus 2, which is 8, 8 is less than 8 or not. No, so no need to print. Up to this you have to print. So you have added plus 2. Here the output we are getting is just n by 2, which is the number of outputs we are getting is 4. Okay, the number of outputs we are getting 1 2 3 4. So 4 we are getting based on the n value and based on the plus 2. Like if plus 2 is there, so the number of times it is running is n by 2. The output we got is n by 2. Simply you write n by 2. And to check, to stop for to stop this one, it will be stopped like we have already studied. If I value is equal to or greater than n, then it will stop. So stopping we are writing plus 1. Then though it is inside the loop, you have to write n by 2. Then total the time complexity will be 1 plus n by 2 plus 1 plus n by 2. So you add everything, so it will be n plus 2, or else you can write big of n will be the correct answer. Yes, if you want to say, or big of n plus c will be the correct answer, where you have to write where c is constant. Okay, so then only you can say it is correct for this complexity also. Next example, this is example 2 and this is example 3. In third example, what exactly you have to check, within the for loop there is another for loop written. Okay, so simply you have to write it how many times it is running, one time. Okay, so here to check this one, we have to first go through one by one. So we have seen the internal loop. Always whenever you are focusing on the first loop, better we focus on the internal loop, whether internal loop is there any fault or not. If there is no fault, directly you have to read, you have to write, uh, I have found there is no problem in the internal loop, like there is no such infinity or nothing else is there, so everything is fine. So that's why I'm just writing it n plus 1. Why? Because plus 1 for the stopping condition it has to check, and though it is written within the for loop, that's why I'm saying, so everything whatever that I am writing inside this, I should have to write, the n is there. Okay, for n will be getting multiplied, and again it has to run for n plus 1 time. Why? Because it is a for loop condition, it will run for n plus 1 time, though it is inside the for loop and inside the upper for loop, so it has to run for n time again. Okay, so that is why n into n we have to write. The space complexity then, sorry, the time complexity, we have to find is, we have to add everything, 1 plus n plus 1 plus n into n plus 1. Okay, then plus n into n. So overall will be n plus 2 plus n square plus n plus n square, where you are getting 2n square plus n and 2n square plus 2n plus 2. Okay, you are getting this one. So out of this, 2n square is greater than all of this, so to time complexity you should write as 2n square, or else if you want to write c into n square, this is time complexity, not an issue, this is correct. But you should remember always the internal loop, there should not be any problem. Then fourth will be, so here I is getting multiplied with 2, so your target should be how the output will look like. In that case you can check the printing condition of it. Print, suppose print I. In that case, whenever you are going for the printing of I, Your target should be when I is 1. Suppose let us take n could be anything, n could be 10, 20, 50, anything. Okay, in that case it should be less than that. So 1 will be printing, not an issue. Second, 1 into 2, 1 into 2 will be printing 1, then 2. Okay, then the I value will be 2 into 2 will be printing, because 2 will be the value which is getting multiplied here. Okay, 4, like this you will get. Also I'm going for another one here. 4 will be multiplied with the 2, okay, which is 8, like this. If you are going downwards, like the number of times if you are finding, then it find a pattern. 2 to the power 0, go for a pattern. It will be better, like how when then will stop, because we are actually planning for the aim. We should have to stop by assuming that we stopped for a while. Let us go for a property, like we think we have stopped somehow. For k times I'm running one. Once I'm running for k times for first time, for this is our first time without running the dust. We have checked the condition. First time it is running, second time it is 2 to the power 1, third time it is 2 to the power 2, fourth time it is 2 to the power 3. So for k plus 1 time or k times, suppose you are saying, so your k times, that could be 2 to the power k minus 1. The value would be 2 to the power k minus 1. Why? Because for 4 it is 3. So 3 it is 2. So it's k minus 1 for, let us take, okay, an example then. Then what will be there? Here, next, assume the value you have already reached is I is greater than n. So it's better you can say I if I equal to n. In that case, what you have to do is 2k minus 1. I value is 2k minus 1, because I is running for that many times. Okay, equal to n. Then what you have to do, you have to find the kth value. For finding kth value, take the logarithmic with the base. Where k is there, take that as base. Okay, log 2 to k minus 1, here log n base 2. Then you'll find k minus 1 will be outside. Okay, and log 2 base 2, this side is log n base 2. Here base 2, log 2 base 2 is 1. Okay, where k minus 1 equal to log n base 2, and k is log n base 2 plus 1. That plus 1 you can ignore, because this is a constant is less than the logarithmic. That's why you can say, uh, you can ignore that for a while. Once you are ignoring that, the number of times actually we need to find. If we can find the number of times, then only we can say it's a time complexity for us. We're not going to solve anything, but we are trying to find out the number of times how we are running. So here k we found is logarithmic with a constant, so that's why we are saying logarithmic time it is running. Or else, practically if you want to say, we go log n base 2 plus a constant is getting added. Okay, that is also correct answer for it. But better the theoretical answer we are running, that's why the complexity is this. So like another program is like here also we are printing that. By printing the value of I, then only we can go for it. Like first it will be like I, which is the value, I value is n for a while. Like you can say if it will print n first, next n will be checked with whether the value is greater than 1, that we said n is a bigger value, it will be greater than this. Then it will be divided means I value will be n by 2, next n by 2, next time will be n by 2 square, next time will be n by 2 to the cube, because by 2 by 2 by 2 will be there. So the first time, for the second time, for the third time, for the fourth time, the fourth time it is there. So for k times suppose you are running, so it will be like 1 1 minus. Okay, so n 2 to the power k minus 1. This is the output that you're getting for k times, but number of times that you are finding exactly is the time complexity. You are not going to solve anything, the number of times you are running. Yep. So assume, you have to go for assume you suppose the it will be false if this happened. So better you can write one I equal to 1. The value of the I is n by 2 to the power k minus 1 is equal to 1. Then n you will get as 2k. This is what you found. Now I told you, if you want to get the kth value, you take the logarithmic with the base. If 3 is there, so base 3 will be written. Here 2 is there, so I am taking base 2. Both the side use log 2 base n, log 2 to the power k. Okay, so here log n base 2. Always take 2 base. If k is on a power, always take that one as a base. Okay, here I have taken this as base. Now you can say uh, n log n base 2 this side, k minus 1 this side, log n base log 2 base 2. Log 2 base 2 is 1. So here in general we found k minus 1 is equal to log n base 2, and you can write k equal to log n base 2. So here we are finding the number of times it is running. So you can say the time complexity is log n base 2. It's correct. Also, if you are writing plus 1 that we found, because plus minus 1 is here, or else you can say big of log n plus c. That is also the correct answer you will expect. Okay. So this is your fifth one we discussed. Sixth one now. Okay. Remember how we are running based on the number of times it is running. Let us think it's I square now. Okay. Like we have to check. Suppose n could be anything. N could be a bigger number there. Huh? So we are running for I square. Like you can say, suppose n is 3 now. For that, whenever you are finding, suppose n is 8, that could be a better answer. We can start from 9. Suppose n is 9 and we started with our presentation. So 0, whether 0 is less than 9 or 9. If it is, then it will print 0. Next I plus plus, or I plus plus 1 into 1 will be less than 9 or not. Yes, it is. Then print 1. Next I plus I, which is I plus 1, which is like this, whether 4 is less than 9 or not. Yes, to print 4. Next 5 into 5. 5 into 5 is not less than 9, so it will not print anything. How many things have been printed? Only 3 values got printed based on this multiplying concepts. Okay, due to I square, so we can find the 3 values, which is indirectly you can say, okay, which is indirectly you are saying the number of times actually we are getting is due to I square. We are exactly getting it for the root over time. Okay, so the time complexity it is taking is n to the power 1 by 2. Okay, that is correct. Big of root n also you can say it is also correct, or else you can say big of n 1 by c also you can write. These are the correct values for finding this one. Based on the output, you can go for it. Now, this is seventh one. Okay. So here in seventh, there are two different for loops have been written. So you have to check whether there is a problem or not. No problems we found till that. So simply it is running for one time. It is running for n plus one time. Though it is within that. So the number of times the for loop is running will the number of time it will run. Here also the same thing. N plus one time it is running. Here also it is running for n times. Next, to add this time complexity will be like you are adding 1 plus n plus 1 plus n plus n plus 1 plus n. So the total will be 4n plus 1 2 3 4 4n plus 3. Okay, so out of this, the time complexity could be written as n. This is correct. Or else you can write big of c into n could be correct. Or else you can write big of c into n plus c also being written. But you should have to mention where c is constant. Then only it will be correct. Otherwise, might be a wrong answer you are writing. Okay. So it is eighth one. Here, what exactly we are going to check? I told you always focus if there are two for loops or four for loops or whatever the for loops, if inner for loops that you are finding, so first you focus on the inner for loop, whether it is running fine or not. As for the previous one, we know it is running for one time. It will run based on the number of times whether there is a problem or not. Here we didn't find any problem. So we can simply say it will run for n plus 1 for to stop it. Next, though it is within the for loop, so the first for loop will be written to check this one. The first for loop is running for n time. It will be multiplied then. This for loop we recently studied multiplied with 2. If multiplied with 2, so the base will be written like this. Okay, if j cross 3, then you can say it's log 3 m. If it is written with the n, you can write it is n, which is 1. Okay, so the multiplications you are doing will be the number of times you are actually the you are keeping the base. Okay, now you are actually, it is though it is inside it, whether it is running for log n plus 1 time. Now though it is inside the first loop, you have to write, and for second loop you have to run for log n time only. Next, the total time complexity will be, or time complexity will be 1 plus n plus 1 plus n log n plus n, that I have done that expansion. Next, n log n base 2. Here you add everything, 2n log n base 2 plus 2n plus 2. So here the maximum you are getting is big of n log n. So the time complexity will be big of n log n base 2. This is the answer. If you are saying c into n log n, also you can write c into n log n into n, also you can write. Here n is uh, lesser than the n log n, that's why we are writing as the time complexity. And the ninth one will be a tricky one. As for this, whenever you are running for one time, next you have to check the second loop, and here in this inner loop you have to check whether inner loop is fine or not. You can check if it is 1, now it will be less than 1, it will print, any value will be printed. When it is coming there, so j value is equal to j value, not an issue. Again you can come, so j value will be printed. Again you have to come here, j value will be equal to j. Like it's a cycle, cycle, like you are actually within a infinite loop. If you are within the infinite loop, you cannot come outside. Though you cannot come outside, simply write the maximum time complexity of n to the power n. That could be better to express it. Next, it we just run for one time and we have checked the condition. Once the condition is checked, well, then we found that we cannot return back here, though we cannot return to the first for loop. That's why the total conditions as for the time complexity, the complexity will be the higher the maximum, which is super polynomial. Super polynomial. Do not say it's exponential, because n to the power something is considered as polynomial. So n to the power n is written, it is super polynomial. As per the old professors there in MITs and other universities, they are considering these as super polynomial rather than saying it's super exponential. By saying it's super exponential, it is a wrong concept we are generating, because the super exponential means exponential, we can say constant, means some constant power of n. It is wrong. Super exponential is constant to the power n, but polynomial is n to the power some other constants. But though n to the power n we are getting, that's why we are saying it is super polynomial. Okay, rather than it is super exponential. We should say it, and this is by default that we found why we are saying. Okay, so in this way, the original code, you can say, is like Abhimanyu. Abhimanyu knew that entering into the path, but he doesn't know about how to get out of it. This is the problem. Might be if infinite loop would be there, you can use this. So as per the note, so the note what it tells, whenever you are saying the multiplication, suppose j is getting multiplied with 4, in that case log base, that will be considered as the base, and you can add this one. Suppose j is like divisible by 8 also, in that case log 8 n. So this 8, it is divisible by, like as per the previous examples which we have seen, that is I'm saying, like whatever it is getting multiplied, what is there inside. Or suppose it is adding, okay, suppose 20 is getting added, so n by 20, the plus we are using, here we are dividing that one. Okay, this is how we actually finding the time complexity. I hope it is understood by you, and thank you for watching. Have a good day.